Al-Marifa International Private School, Thermal Physics, IGCSE 0625. Learning objectives. 223 Thermal capacity or heat capacity. Core. Relate a rise in the temperature of a body to an increase in its internal energy. Show an understanding of what is meant by the thermal capacity of a body. Supplement, give a simple molecular account of an increase in internal energy. Recall and use the equation of thermal capacity, which is equal mc. Then define specific heat capacity and describe an experiment to measure the specific heat capacity of a substance. Then recall and use the equation, which is change in energy is equal mc delta T. Now, as you see here in this slide, we have 1 kilogram of water, and also we have 1 kilogram of aluminum. Now, the question is, which material requires more energy to heat up by only 1 Celsius? 1 kilogram of water or 1 kilogram of aluminum? So after doing the experiment, the 1 kilogram of water needs 4,200 joules of energy, and 1 kilogram of aluminum needs 900 joules of energy to raise its temperature only 1 Celsius. So as you see here, water must be supplied with around 5 times of energy more than aluminum to raise only 1 temperature. And this is because of specific heat capacity of the material. So the specific heat capacity of a substance is the amount of energy needed to change the temperature of 1 kilogram of a substance 1 Celsius. So as you see in this table, we have 3 substances: water, oxygen, and lead. The specific heat capacity of water is 4,181 joules per kilogram Celsius. So to raise the temperature of 1 kilogram of water 1 Celsius, we need 4,181 joules. For oxygen, the specific heat capacity is equal 918 joules per kilogram Celsius. For lead, it is 128 joules per 1 kilogram Celsius. So to raise the temperature of 1 kilogram of lead 1 Celsius only, we need 128 joules. So as you see, water has the highest specific heat capacity of the all. That's why it is useful to store heat and also for transporting it, such as central heating. Now, the equation that we have to use, as you see here, energy transfer will be equal mass times specific heat capacity times temperature. Energy transfer will be equal mc delta T. Now, where m is the mass and the SI unit is kilogram, C is the specific heat capacity and the SI unit joule per kilogram Celsius, and delta T is the change in temperature, which is in Celsius degree unit. Now, the arrangement of equation, as you see here, energy transfer, mass times temperature, change times specific heat capacity. In the first equation, if we need to measure mass, so in this case, change in temperature over specific heat capacity times energy transfer over change in temperature times the specific heat capacity. Now, delta, the second one, if we need to measure the specific heat capacity as this box, we need to calculate or to rearrange the formula into energy transfer over C times change in temperature. And the third one, if we need to measure the change in temperature, so we need to divide energy transfer over specific heat capacity times mass. This is how to rearrange the equation to measure each variable inside the equation based to the questions. So now the one of the examples, how much energy needs to be transferred to raise the temperature of 2 kilograms of water from 20 Celsius to 30 Celsius. So how we will use the equation of energy transfer. As you see, the energy transfer, again, the equation E is equal M times C times change in temperature. Now, in this example, the mass is 2 kilograms, and we know that the specific heat capacity of water is 4,181, and the change in temperature based to the question is 30 minus 20, so it will be 10. So the answer, the energy transferred, is 83.62 kilojoules. So we need this amount of energy to raise the temperature of 2 kilograms of this material, 10 Celsius. Now the thermal capacity. Thermal capacity is mass times specific heat capacity. And this is one of the examples. If we have 3 kilograms of water in a kettle, so the thermal capacity will be equal the mass of water inside the kettle times the specific heat capacity. So 3 times 4,181, the answer will be 12,543 joules per Celsius. So as you see here, this means that for every 1 Celsius raise in temperature of the water in the kettle, 12,543 joules of energy need to be supplied to this material. Now, measuring the specific heat capacity, this is the requirement experiment. Keep in your mind that we need to use this equation, energy equal power times time. Now, if we have power, so the equation will be energy equal power times time. If we have voltage and current, the equation will be energy will be equal voltage times current times time. As you see here, we have, as you see here, I will return back to this one. So we have a beaker that is contained of 0.75 kilograms of water. And also we have a heater that immersed here. This heater is 200 watts. The time of switching on the heater will be 200 seconds. Temperature of water raised by 12.5 Celsius. Now we need to calculate the specific heat capacity. As you see, energy transferred will be equal power times time, the time in seconds. So 200 times 200, so it will be equal 40,000 joules. Now, as you see in the second one, we need to calculate the specific heat capacity. So we have to rearrange the formula. When we rearrange the formula, as we explained before, the specific heat capacity will be equal 4,267 joules per kilogram Celsius. So this is in a practical way. So as you see, the actual value of the specific heat capacity of water is 4,181. Now, the method described does not make any allowance for heat loss to the surrounding or the beaker. So this is the general description of the experiment. Now let us to go to details. As you see here, we have 1 kilogram of aluminum and we have 1 kilogram of water. What are the instruments we need and what are the variables we need to measure? As you see, 1 kilogram and 1 kilogram of mass is the constant variable here. And instruments we need a heater that immersed inside water as well inside aluminum. Also, we need a thermometer to measure the change in temperature. We need also a stopwatch to measure the time interval for both blocks or both kilograms. Now, what are the variables we need to measure? For sure, the heat resource with 36 watts, and also the same for the second one. So this one will be constant to compare the specific heat of water compared with the specific heat with aluminum. Also, we need to measure the change in temperature by the thermometer. Also, as you see, we need to measure the time taken for water and the time taken for aluminum to raise its temperature only 5 Celsius. So the constant variables, the value of power inside the heater. Also, the constant variable is the change in temperature, which is 5 Celsius for both. Mass also is constant. Now, what we need to measure, as you see for the first block, we need to measure the energy, which is equal power times time. The power is constant, which is 36, times the time will be taken by the aluminum to raise its temperature 5 Celsius. And also the energy in the second one will be equal power times time. The power is constant times the seconds, the time that will be here. So we will keep the starting temperature for both is same. Then we will start to measure the time that is taken by both to raise the temperature or change the temperature only 5 Celsius. In this experiment, the conclusion will be the time that is taken to heat up the water 5 Celsius will be more than the time that is taken to raise the temperature of 1 kilogram of aluminum 5 Celsius. And the reason that the specific heat capacity of water is much higher than the specific heat capacity of aluminum. So as you see here, this is the experiment summary. Now the specific heat capacity of water used in a lot of applications. For example, in central heat system, water carries thermal energy for the boiler to the radiator. This is one of the applications because of the high specific heat capacity of water. Also, the other application, in car cooling system, water carries unwanted heat energy from the engine to the radiator. These are the two applications of using the high specific heat capacity of water in life. Let us to see one of the example of questions from past paper 4. As you see here, a student in a laboratory used the apparatus shown in the figure to determine the specific heat capacity of aluminum. This question is related to the previous experiment that we explained before. So as you see, the readings obtained in the experiment are given below. Now the mass of aluminum block is equal 0.930 kilograms. Now the starting or initial temperature will be of the block will be 13.1 Celsius, and the electrical energy supplied will be equal 23,800 joules. Final temperature of the block will be 41.3 degrees Celsius. Now in branch A, what they need use the reading above to calculate the specific heat capacity of aluminum and state the equation. As you see here, this question has 3 marks. We have to state firstly the equation. What we need to measure, firstly we need to measure the delta T, final temperature minus the starting temperature, 41.3 minus 13.1. The change in temperature in this experiment will be 28.2 Celsius. Now the mass is 0.930 kilograms, and the energy supplied, E or Q, will be equal 23,800 joules. When we rearrange the formula to have or to calculate the specific heat capacity, the rearranging will be Q or E over M times delta T. When we substitute all numbers, the specific heat capacity will be equal 907.5 joule per kilogram Celsius. So the meaning of this, that to raise the temperature of this mass 28.2 Celsius, so the energy or the amount of energy here is Q, which is what? Which is 23,800 joules. Now to raise the as you see, the specific heat capacity will be equal 907.5, or it is, yes, 907.5 joules per kilogram Celsius. The second one, as you see in the second one, B, he carries out the experiment again, supplying the same quantities of electrical energy. This time, the temperature reading, the initial temperature or starting temperature will be 41.0 Celsius. Final will be 62.1 Celsius. Now use these figures to calculate a second value of the specific heat capacity in this case. So as you see, we have other change in temperature, but we have same mass, same energy supplied. Again, we have to measure the change in temperature. In this case, it will be 62.1 minus 41.0. The answer will be 21.1. The mass is same, energy supplied is same. Now, when we rearrange the formula to have the specific heat capacity, it will be equal Q over M times delta T. Now, as you see, when we substitute the numbers, we will have the new specific heat capacity, which is 1,212.8 joules per kilogram Celsius. So to raise the temperature of 1 kilogram of this substance, 1 Celsius, we need 1,212.8 joules. Now, if we want to compare between the two experiments, as you see, the constant variables here, the amount of energy supplied, which is a Q or E. Now the mass is same. As you see, the change in temperature is different. Change in temperature is different between this one and this one. That's why the specific heat capacity will be different in both cases in the previous question. This is the comparison between branch A and branch B in the previous question. And this is the end of the summary of this session. Thank you.